Okay, we're good to go. Last experiment we want to do with our little vacuum pressure pump is looking at the relationship between pressure and boiling point. So we've got water here which was boiling, it's cooled down a little bit, it's now at about 70 degrees, so I'm going to pour it in here and take the temperature. So just hot enough to put your finger into it. Just focus on the reading there if you can. Peter, you got it?
Yep,
What reading is it?
72.5.
72. So see if we can get water at 72 degrees to boil. Put it in the pressure pump. And of course there's all sorts of discussions that this will then initiate, which is why does it boil at a lower temperature? But let's just see if we can get it to work first of all. So away we go. Is that boiling?
Yeah.
Whoa.
You're impressed?
Yep.
Thank you very much. We're not finished yet. Okay, so we definitely got it to boil. Now, can we keep it boiling if we keep pumping? So the condensation is there, so it's not quite as obvious, but you can just make out that the boiling is happening. A couple of very quick variations on that. Okay, so we have skirted over the whole question of why that's happening. Very quickly, just to show, you don't need, while this isn't fancy, we said the cost here is only about 20 euros from Amazon. You could do the very same thing with a syringe. Let's do the other way around. Let's use the syringe to take up the water. Notice I'm not using the word sucking, because sucking is not a term we like in physics. Let's get out any excess air. And we're going to create a vacuum using my syringe. I just need a little bit of tissue paper to put at the end. So this time to create a vacuum, what I'm going to do is, and I need to stand up actually, I'm going to be bending down for this. You okay with that?
Mm-hmm.
So I put my finger over here, but it's quite hot because the water is quite hot, is it? Yeah, it's not too bad. And this time I'm going to create a partial vacuum by moving up the top of the syringe. Okay, so we go 3, 2, 1, and keep an eye on the water. 3, 2, 1, and up it goes. And you've got boiling water. Same idea. We haven't discussed why it's happening, that's for another day. 1 to go. Let's stick all the water back in here. And just make it a little bit more impressive. So there's our water. It's now at about 70 degrees. We're going to finish up with this. Same idea. Whew. And away we go. One last time. Perfect. Okay, so this time, just a little bit more impressive, the more water you got. Same idea. It doesn't matter. Will the amount of water affect the temperature it will boil at?
No.
It shouldn't, so it should still boil at the same temperature at the same pressure.
There you go.
It's a little bit more impressive if we got more water in there. And once it stays at that temperature and that pressure, it should remain boiling. When will it stop boiling?
Whoa. Cools down.
Pressure turns back.
Why would the pressure inside there change if I've taken out some of the air?
Condensate.
Not quite condensation, but what have you got from there? Yeah, you've got the water vapor. You've got the water, which is now turned into water vapor. So now there is more greater air pressure in there than there was when I removed all the air. So it would remain boiling until enough of that water has become water vapor, such that that pressure is enough to prevent other water molecules jumping into the air. Cool? Thank you very much. A round of applause.